Hello guys, this video is about my math cube. Excuse me, I have been working on it. It relies on operators, and if you don't like math, obviously you don't have to watch this. Probably isn't your video, and I don't even have to write my name on this, but I will, because it's my habit. And it's a good habit. So we're going to make we're going to make multiple math cubes and see that these properties are true for every number. There's going to be two sides to this cube, a positive and, negative side. And these properties must be true. The positive and negative cancel. All 6 operators are used, and there's 6 basic operators, which I can write down on the back. That'll be plus, minus, multiply, divide, and then plus and minus exponentiation. So that's 6. And you got a really interesting cube. So let's draw a cube. This is one box. I shouldn't have drawn it like that. It's not very efficient. Let's see. How many can we get in just one line? I'm just gonna ignore this cube that I made over here. I shouldn't have started there either, but I think I lost. I lost already. I bet if I had a few tries on trying to draw all of these non-squares with one line, I would eventually win. I miss. But that's not the topic of the video. And maybe next video, if we have a non-square cube, I'll do that for you guys. We're going to change to red. So in number world, 0 is neutral. So for a cube, if we're going to encompass all numbers, positive and negative, we have to have neutral ground. Base. And we'll make the front side the positive side, the back side negative side. Should have just left the N side. So it should say. That looks weird, but it says N side. And our number, we're dealing numbers because we have to take into account both positive and negative properties of the number. So the digit we're dealing with is +2 and -2. This is obviously positive, and this is obviously negative. So now what do we do? Well, for the positive side, everything revolves around 1. Because 1 is... I should probably write this down. One and -1, +1 and -1 are states of existence or anti-existence, because according to, I think it's a quantum theory of polarization. If I'm wrong, correct me in the comments below. I didn't study for this. Perhaps I should have. For every matter of positive, for every positive piece of matter, there's a negative piece of matter to counter it. And the universe was created by polarization. So for all positive, there's negative, so that's polarization. Anyways, so of course we have, excuse me, we have, oh, I switched the black, +1, and -1. Now we have to start putting the operator. So obviously this is plus, minus. Now we have to multiply. And why don't we multiply by positive? So going up, why don't we multiply 2 by 1? Got +2. And on the negative side, we can multiply on the opposite end of the cube. We can multiply by the opposite of 2, which is we can multiply by the opposite of 1, which gives us the opposite of 2. It's the opposite sides of the cube by -1. And now we need to fit an exponentiation. And seeing that this is positive and this is negative, well, we already have 2 to the 0th here. 2 to the first. So 2 to the negative first would be natural. And these two cubes are really interesting because they're you'll see later. So this is to the negative first. We get +1/2, and you see, even on the negative side, numbers are going closer. They're getting bigger, because -1/2 is closer to 0 than -1. So it'll still be 2 and it'll still be -2 to the negative first. So you might say, hold on, -2 to negative first. Well, if we want the cube to be like the same, you could say, so -2 to the 0th wouldn't be -1, some would say, because everything to the 0th power is 1. But this is negative of 2. We're keeping all the properties of a positive number, and then we're making it negative. So it'd be like I kind of wrote that funny. And I wrote it in red. I forgot to switch colors again. You can tell this is my first math video. Or first one in a long time. I think I might have posted one a while back. Or I might have just shared it with my friends or something. So there's a difference between this and what we're talking about is this. First we got 2 to 0 and then negative. Because otherwise the values would always be positive, because exponents are otherwise always positive. Think about it. 2 to the 0 is -2 over -2. 2 to the... Well, they're always positive fractions, is what I meant to say, I think. This is weird. I'm having a mind block. But if you take -2 to the -2nd power, never mind, that's different. Anyways, this gets really weird. Forget everything I just said about powers. It's all wrong. It's late. So this is what we're talking about, okay? And that's the end of the square. So let's just go over the square because I know it was really long and writing the square and very wordy. Positive, negative. Okay, positive side, negative side. Multiplied by 2, multiplied by 1, multiplied by -1, to the 1/2 power, and this is -2 to the 1 power, not 1/2 power, to the -1 power, so it's the inverse over here. And then that's pretty much it. That's all the 6 operators that we need. It's a beautiful cube. And now here's the part where those on the end are weird. So if we add up these 3 on this side of the cube, you can see the positive and negative line. And these 3. So where do these blocks belong? Because this is technically in the back, but it's also on top. And this is in the front, but it's also on the bottom. And the bottom is going down, negative. So we have a trade-off, kind of, because this is still, the sides always prevail, the negative and positive side. So this would be a negative. So there, you get 2 L's. 2 L's. Not just 1, but 2. You get a negative that would stay on the negative side, and you get a positive. So the sides would actually be 2 L's wrapped around a 0. And then in the next video, I think I'll expand on the cube and be a little bit less talky. Thank you for watching. If you made it all the way through. I hope you enjoy my cube. If you have a cube of your own that you'd like to share, or you'd like me to make a bad video of, my videos aren't that bad, you could ask me. Thank you for your time, and have a nice day, night, evening, morning, or however you like.